Okay, so the B part, question B is about this going up motion. So if it's going up, same way we can say it's going up. So look at this point. There will be, now there's no FP. No FP here, just let go. So the force will be MBG, and buoyancy will be like that. So we can use a work energy theorem to figure out in these two instances, and supposed to be ignore F viscous. If you ignore this, then energy here minus energy here is, will only be, difference will be equal to work done by FP. So if this displacement going that way, then we have, so this is, let's look at energy at B minus energy at A equal to, and this is going to do positive work because I'm going from here to there. So work done by force of buoyancy, and which is this quantity here. So it's going to be, so now let's look at the whole thing. EB is going to be, over here is speed V. That's the V we have to check if that's the case, of MBV square, plus it's going to have potential energy with respect to A. So potential energy gravity equal to 0 here, reference. MBGD. So this is for the B, and for the A, V is 0 here, and presently 0 here is actually 0, and the work done by this is just 4/3 by R cube rho B GT. So if bring this on the other side, what you get is half MBV square is this stuff minus this stuff, but which is the same as that, which is equal to 0.077 joules. So if I put 2 times 0.077 over MB and put MB there, MB is 22 over 7 times 10 to the minus 3, and this is 77 times 10 minus 3 times 2. You can see it becomes 11, and this 11 cancels 7, and this cancels that. This 7 times 7, and this is the speed, so V equals to plus 7 meter over second. So B is correct too. Viscous, if you neglect viscous force in water, then the height will be this, which is the same as is coming out here, part 2 going up. So it's about this part of the motion. So C about part 3 of the motion. And let me erase this and try to work it out, okay? Okay, so this is just one-dimensional motion, and acceleration is pointed that way, and this is like V square equals to GH. There's no viscosity or anything here. You can ignore everything here. It's just one-dimensional motion. So H is big H. So H equals to V square, and this is given at 7 meter per second. 2G, and so V7 is 49, but 2 times 10, so 4.9 over 2 is 2.45, and which is not equal to 1.4 meter. So this definitely is not correct. Now D, it just overall, it's saying viscous force is maximum, and the net force if you is like was if you look at the net force, it's trying to say go back to go up part of the motion. So the net force on this is mbg and force of buoyancy. So the F net is F of buoyancy minus mbg, and compare that compared to the F viscosity max. Now, where will the viscosity be max? Well, its ball is here. It's coming out over here. Just emerges at 7 meter per second. Just underneath this surface, we assume that this is also 7 meter per second. So that's where it's inside the liquid, and it's moving 7 meter per second. So we can use the maximum velocity for that. So that's going to be 6 pi eta r v max, which is equal to this is equal to 7 meter per second in this present case. So if to compare this to that, now this is get the numerical value. So FB minus mbg over 6 pi eta r times 7. You compare that, and I've done this work, and I made sure that put the numerical value which comes from working part A. In part A, you have already worked out this numerical value, and just plug these values in, and this indeed it's going to be 500 over 9. So just for the sake of saving time, I'm not working this out, but you can work out the numerical part. Okay, hope this helps. I'm going to stop here, and I will see you in another video. Bye.